Okay, Assalamualaikum to all. Okay, this is the to continue what we have done yesterday. Okay, at this point, you already recognize this curve. This is soil characteristic curve. Okay, we get this one from the data. This data is from lab activity. So you go for lab activity first, get the data. From the data, you calculate or analyze using this form. After you analyze the form, you get the soil characteristic curve. And we already do the composition, meaning that we want to find what is the percentage of gravel, what is the percentage of sand, and then what is the percentage of fine material. So we have already done the composition. And for yesterday exercise, we have concluded that this data, when we refer to British standard, we get the name of the soil as gravel because of the composition of gravel is the dominant composition. But another thing, before we conclude what is the exact name of this soil, we must do what we call as characteristic size. Okay, for characteristic size, okay, what you need to have is these three size of soil. Okay, D10, D30, and D60. Okay, at 10% of the soil, what is the diameter of the soil particle? At the 30% of the grading curve, what is the soil particle? And at the 60% of grading curve, what will be the particle size? Okay, let's see what is actually I'm explaining right here. This is D10, and D10 is located at 10% of your grading curve. So use your ruler and then use horizontal line and point which the line will intersect with your curve, and then do the vertical line to find what is the size of particle at 10% of this grading curve. So with this, D10 is 0.27. So what we need to do from the curve, okay, write down the value of 0.27. Okay, next you must find at 30%, which denoted by D30. Okay, what will be the size of D30? Again, draw the horizontal line, which one is intersect with your soil curve, and then you draw the vertical line and read what will be the size. The size is 1.6. So that is the value you jot down for 30%. Okay, next we need to calculate what will be the size of particle at 60% of this soil curve. So the same thing you do, draw horizontal line, find the intersection with your curve, draw the vertical line, and then you read the soil particle. In this case is 5.3. So you get for 60%, or D60 is equal to 5.30 mm. So what next after we get this data? Okay, this data is important for us to calculate for coefficient of uniformity. The coefficient of uniformity is for us to know whether the soil is well graded, gap graded, or uniformly graded. And the equation that you need to use is Cu is equal to D60 over D10. Okay, we already jot down all the value. Okay, use this equation, replace the value and then calculate, you get Cu is equal to 19.6. Okay, that is how to calculate for coefficient of uniformity. Okay, next we have another thing to calculate. What is the coefficient of gradation or coefficient of curvature? For coefficient of gradation or coefficient of curvature is given by Cg is equal to d30 squared divided by d60 times d10. So use the value, calculate, and then you get Cg equal by 1.78. Okay, for the percentage of particle, we already done this before. Okay, we have the composition of gravel at 65%. We have the percentage of sand at 35% and the fine percentage at 0%. So use all of this information. Okay, this one we already done this, and then okay, how to classify the soil? If you get Cu more than 5, it indicates that it is a well-graded soil. So we can use the term well-graded in naming the soil. And another aspect, if we get a Cg in the ratio of 0.5 to 5, it indicate also well-graded soil. So for the example that we already go through yesterday, okay, we already get to this point, and last time we only have the name of gravel, but after you calculate for Cu and Cg, it is confirmed that the soil is well graded. To finalize how to name the soil, okay, after you calculate and then you draw the soil curve, okay, next you refer to the composition, how many percentage of gravel, sand, silt and also clay, and then you do the calculation of Cu and Cg. Okay, now we referring back to the British standard, so it is confirmed this soil name is well graded gravel. And you can also refer to another standard which denoted this type of soil is very sandy or gravelly when we have over 20% approximate proportion of secondary constituent. So for the classifying the soil, grading from BS 1377 and BS 5930, okay, to very specific naming the soil, we have the well graded very sandy gravel. Okay, this one. Okay, we put the words very sandy. Okay, because of last time you get gravel about 65%. This is the primary composition of the soil. And then you have the value of sand about 35%. This is the secondary of your soil particle. So, okay, we have the secondary of sand. Now we are using very sandy. In terms of the completion of the name, it is well graded, very sandy gravel. So for you to have short notes on how to name the soil, okay, again, we repeat all the procedure. The first one, you get the soil sample and then you do the lab testing. The lab that we do is particle size distribution. Okay, after you do the particle size distribution test, we get the data. Okay, from the data, you analyze the data. After we complete the analysis, we will draw the soil characteristic curve. Okay, next from the curve, okay, there is two important information for you to calculate. It is the value of Cu and the value of Cg. And from the soil curve, you want to know the composition of your soil. So the composition is based on how many percent of gravel, how many percent of sand. If available, you can also calculate how many percent of silt and also how many percent of clay. And then after you done all of this, okay, you refer to BS standard. Okay, this is the first table that you refer to. Okay, first determine whether your fine soil less than 35%. And then what will be the dominant composition? In this case is gravel. And then you have calculate Cu and Cg. Now we confirm that the soil is well graded. Okay, next you are referring to this table. Okay, because we have secondary particle which is sand about 35%, so we can use very sandy in the name. As a conclusion, okay, you can name the soil as well graded very sandy gravel, or in bracket SGW. Okay, you can go back and find all the information to really understand all the theoretical part for this classification. And of course, the data is not unique. So different types of soil, you will get different types of data. And the beauty of naming of the soil, you do not know what is the soil classification that you will get. Either you get the coarse particle or you get the fine particle. But right now, what you need to know, a part of this, we have what we call as hydrometer test. And hydrometer test is to classify fine particle of soil. And that one is using hydrometer test. And that one you can learn. If you have any question regarding the wet sieving test, okay, you can first refer to the process of doing the wet sieving in other references. You can also watch YouTube on how they are doing this test. Okay, to compare with the sieving method, this is a wet sieving method. If you are doing using a sieving pen for dry sieving, for hydrometer test, we are using the suspended concept of material, and then we calculate for the times of sedimentation. Okay, and the most important for this chapter is for all of you, of course, to know the process of doing the testing, and then of course to analyze. Okay, make sure that you know how to calculate using the table. Okay, so okay, and that is all to conclude for this topic. Thank you.